All right, so this week we're going to talk about line plots, all right? And line plots are just a way to display different data. So if you look here, this shows a tally table where students who were 4 1/4 feet tall, it was 4 of them. Students were 4.5 feet tall, there were 6 of them. Students who were 5 feet tall, there were 5, and so on and so forth. When you make a line plot, it's just taking that set of data and just organizing it in a different way. So if I know that 4 students were 4 1/4 feet tall, I would just make 4 X's, okay? If I know that 6 students are 4.5 feet tall, I would make 6 X's, okay? Students who are 5 feet tall, there's 5 of them. 1, 2, 3, 4, 5. Students who are 5 1/4 feet tall, there's 4 of them. 1, 2, 3, 4. And students who are 5.5 feet tall, 3 of them. Okay, so it's just kind of a different way of organizing a set of data. All right, so we're going to take a look at a couple more problems that you're going to see that are going to be pretty similar to problems that you're going to see on your test. Okay, so if you look right here at number 1, it says the line plot below represents the different speeds of animals found in the Sahara Desert, measured in miles per hour. Based on the data below, how many animals have a maximum speed of 43 miles per hour? Okay, this one's pretty simple. These are obviously the speeds, 41, 42, 43, 44, 45, so on and so forth. These are the number of animals that have that speed. So there are 3 animals who run at 41 miles per hour. There are 0 animals that run at 42 miles per hour. It wants to know how many animals run at 43 miles per hour. So we look at 43 and we count. 1, 2, 3, 4. The answer would be 4. Okay? Pretty simple. Let's look at number 2 because we're going to use the answer to number 1 for number 2. It says, use the line plot in problem number 1 to write at least 3 sentences to analyze all of this data. Okay, so you get to analyze it 3 different ways. Well, I might say one of my sentences, let's see how many animals there were in all. There was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that's something that I analyzed. There were 19 animals counted. So we know that's a good one we can use. What's something else that we can see here? How about at 42 miles per hour, there were no animals. So no animals had a speed of 42 miles per hour. And what's something else that you can conclude when you look at this? How about that only one animal had a speed of 50 miles per hour. So we kind of made 3 different conclusions by looking at that set of data. Now, could you make more than 3? Absolutely. Those are just the 3 that I chose. You may look at it and find something else. All right, let's look down here at number 3. Number 3 says, make a line plot for the amount of money Renee earned this summer while lifeguarding at the neighborhood pool. So it looks like she earned 20, 25, 30, 15. Okay, so there's lots of different amounts that she earned. When I make a line plot, I don't want to start at 1, 2, 3, 4, all the way up to 70 because that just doesn't make sense. If I look at these numbers, it kind of looks like they're jumping by 5s. It looked like 15 was the lowest number, and it looks like 70 is the highest number. So I'm going to start at 15, and I'm just going to jump by 5s. 15, 20, 25, 30, 35, 40, 45, 50, 55. I'm going to have to keep going. 60, 65, 70. Okay, that's the way that I'm going to do it. So now I need to figure out how many times did she make $15. 1, 2. How many times did she make $20? 1. Do I see a 20 on there again? There it is. 2. How many times did she make $25? 1, 2, 3, 4. And remember, you should see a significant difference. So they should kind of all be lined up so that you can tell the difference. How many times did she make $30? 1, 2, 3 times. How many times did she make $35? I don't see it. How many times did she make $40? I don't see it. How about 45? I see it twice. Okay. She didn't do 50, no 55, no 60. I think the next one that I see that she made was the 70. And she made that once. Okay. So when I look at this, the times that she did it twice, they should be even. So everything should kind of be even so that you can really see the difference, okay? So let's look at number 4. Use the data in the line plot you created in problem number 3 to determine the difference between the greatest amount of money and the least amount of money. Okay, that's the first part. So we know the most amount of money she made was 70, and the least amount of money she made was 15, and they want to know the difference. So the greatest amount was 70, the least amount was 15, and they want to know the difference. So I know that that's 55, so that's definitely the difference. The next part says, is there an outlier in this set of data? If yes, what is the outlier? Well, an outlier is a number that really just doesn't fit. Okay, it doesn't fit. It's kind of either it's way less than everything else or it's way more than everything else. So most of our numbers are falling between the 15 and 45 range. Would you agree? Yeah, I think so. What one kind of doesn't fit in this range? It'd be that 70, right? That's way far out. So that 70 is what we would call an outlier, because it just doesn't fit around the range of all the other numbers. It's kind of way far out. So that would be called an outlier. All right, so don't forget that word. All right, let's look at another one. Let's look at number 6. Number 6 says, this line plot shows the number of siblings students have in a 5th grade class. How many students have at least 3 siblings? So X equals the number of siblings. Okay, X is the number of siblings. So how many students have at least 3? Okay, that person definitely has more than 3. So that person has more than 3. There's 4 there, so that person has more than 3. Only 2 have at least 3 siblings. This person has 3 siblings, 3, and that person only has 2. So what you do is you add that up. Now remember, I wanted to find the kids that had at least 3 siblings. So this kid had at least 3. This kid had at least 3. This one did not. This one had at least 3, and this one did not. So when I add that up, 1 plus 2 plus 4, I get 7 students. So I know that 7 students had at least 3 siblings in that 5th grade classroom. Okay? And here's the last one I want to go over, because sometimes this can be a little bit tricky for people. It says, this line plot shows the number of times that students in a 5th grade class went to the carnival during the month. How many students from the class went to the carnival during the month? Okay, so this is how many times they went to the carnival. These are the number of students. So that's the numbers that I'm looking at. Okay, so I know that excuse me, that 1 student went to the carnival during the month. I also know that 2 students went to the carnival during the month. 3 students went to the carnival during the month. 4 students went to the carnival during the month. No, 6 students went to the carnival during the month. Even though they only went 1 time, 6 of them went. Okay? Even though they only went twice, 1 of them went. Okay? So the difference here is knowing that These are the number of times they went to the carnival. These are the number of students who went during the month. So that's what it asked me. It said how many students. So I know that 1 student went, 2 students went, 3 students went, 4 students went, and then 6 students went. So when I add all these numbers up, I'm going to get 16 students went to the carnival during the month. Okay, so it's really important when you look at line plots that you understand what the X's are and what these numbers are down here, because if you get that confused, it can be pretty tricky. All right, so just continue practicing at home.